What if I told you that in just a few minutes, you can teach an AI to see and understand your hand gestures without writing a single line of code? Today, I'll show you how to train an AI model that can recognize rock, paper, and scissors without writing a single line of code. This is where you watch AI learn in real time, and it's surprisingly magical. Welcome to Clythera Vox, where we explore the fascinating world of artificial intelligence, one experiment at a time. Let's dive in to see how we can train an AI model without writing code. When we say training an AI model, most people imagine huge data sets, complex code, and powerful servers. But here's the secret. The concept of AI learning is actually simple. Whether it's detecting cats, speech, or gestures, the process is the same. Feed data, train the model, test the output, improve. The tool. Today we'll introduce you to a new tool, Google's Teachable Machine. This is what we are going to use today. Google's Teachable Machine is a free, web-based tool that lets anyone create their own machine learning models without writing a single line of code. It's designed for beginners, educators, artists, and students, making the core concepts of AI accessible to everyone. The entire process is broken down into 3 simple visual steps: gather, train, export. Teachable Machine can create 3 different types of classification models. Image models, to recognize and classify different images. Audio models, to recognize and classify different sounds. Pose models, to recognize and classify different body poses. It uses a convolutional neural network, the same kind of AI that powers image recognition in self-driving cars and medical imaging systems. Gathering data. First, let's set up the project. Go to the Teachable Machine website and click the Get Started button. You will see 3 options. For this project, click on Image Project, then select Standard Image Model. This is perfect for classifying still images, which is exactly what our webcam will send to the model. Next is the most important step, gathering data. Your model will only be as good as the examples you give it. Enable the webcam. Click and hold the Hold to Record button. While holding it, move your hand around in front of the camera. Capture many examples. Move your hand left, right, up, down. Get closer, get further away, and slightly change the angle. This helps the model generalize.
Change the name Class 1 to Rock. Change Class 2 to Paper. Show your hand to the webcam while holding down the Hold to Record button to collect sample data for paper. We'll make 3 main classes: rock, paper, and scissors. Next, add a new class scissors and record scissor gestures using the hand. Finally, create a background class and click the Hold to Record button to record an empty screen without the hand as a reference.
Training the model.
This is where the magic happens. Once you have all your image samples, click the large Train Model button on the right side of the screen. This process might take a minute or 2. You will see a loading bar and a warning: don't switch tabs. It's important to keep the Teachable Machine tab active while it trains. Behind the scenes, the neural network is analyzing every pixel pattern, figuring out what makes rock look different from paper. When it's finished, the preview panel on the right will automatically turn on your webcam. Look at the preview window. It shows your webcam feed and a set of output bars for each class: rock, paper, scissors, background.
Testing the model.
Make a rock fist. You should see the rock bar jump to 100%, or very high. Make the scissors gesture. The scissors bar should jump to 100%. Open your hand to paper. The paper bar should jump to 100%. Move your hand completely out of the frame. The background bar should jump to 100%. If the model gets confused, it thinks your rock is paper, go back to phase 2 and add more image samples to the class it's struggling with, then click Train Model again. You can keep improving it as much as you want. Let me explain some terms used here so you understand what's going on. The epochs show how many times the model studies the data. If you have set epochs to 50, that means it goes through this sample data 50 times to train the model. Batch size is the number of samples in a batch. If you have 80 images and your batch size is set to 16, the processing of samples will be done in 5 batches. Once all 5 batches are processed, one epoch is complete. The learning rate is a setting that controls how much an AI model changes in response to errors it finds during training.
Let's see the effect using a simple example on a graph. Let's say you need to find the minimum point in this graph starting from one point. Learning rate is like a step that you take from one point to the other. Adjusting this will have different effects on training properly. Optimal step size will get you to the solution.
A high learning rate or big steps make the model learn quickly, but might bounce back and forth and never find the optimal solution. A low learning rate takes tiny steps, so it will take a long time and more computational power to train. This might get stuck in small dips, local minimum, and might not find the actual solution. So you need to carefully adjust this value. Also, you can see some under the hood data. Accuracy per class is calculated using the test samples. Once the training is done, you'll see a confusion matrix. It sounds complicated, but it's basically a scoreboard of how often the model gets each prediction right. If your model mixes up rock and paper, don't worry. It's literally learning from confusion. Accuracy per epoch. When the accuracy goes up, that's your AI getting smarter right before your eyes. Loss per epoch. The loss going down means it's making fewer mistakes. You can even export this model to use it in a website, an app, or even a small robot project. That's the beauty of no-code AI. It bridges creativity and technology. You just watched an AI learn visually, intuitively, and interactively. And that's the foundation of every AI system in the world, from ChatGPT to Tesla Autopilot.
If this sparked your curiosity, imagine what you could build next. Like, what if we trained AI to recognize emotions or your handwriting? Subscribe to Clythera Vox, and let's explore how far we can teach machines to see, think, and create. See you in the next one.